what the horizontal looks like. And also this is
First things first, I'ma say all the
Hey
way.
guys, this is group 1 and we're going to have a tutorial about the conics.
which is particularly the hyperbola.
Good day, Carolinans. So we're here today to tackle one of the conics, which is hyperbola. So what is hyperbola?
Hyperbola, the set of all points in a plane whose difference of distances from two fixed points called the foci is constant.
There are two types of hyperbolas, the horizontal and the vertical hyperbola. So this is what the horizontal hyperbola looks like, and also this is the vertical hyperbola looks like. So you can easily identify if it's a horizontal hyperbola if the minus sign is on the y, and if it is vertical hyperbola, the minus sign is on the x. So the standard form of a horizontal hyperbola looks like this: x minus h squared over a squared minus y minus k squared over b squared equals to 1. And a vertical hyperbola is y minus k squared over a squared minus x minus h squared over b squared equals to 1. So the general form of the hyperbola is ax squared plus by squared plus cx plus dy plus e equals to 0. Whereas a is the element of the positive real numbers and b is the element of the negative real numbers. Or a is the element of negative real numbers and b is the element of the positive real numbers. These are the parts of a hyperbola: the center, the vertices, the foci, and the co-vertices. The value of your a is the distance from your center to your vertex, while the value of your b is the distance from your center to your co-vertices, while the c is the distance from your center or foci.
Let's try this equation. X plus 5 squared over 6 minus y minus 2 squared over 4 equals 1. In this equation, this is horizontal because the negative sign is on the y. As you can see it here, it is being squared. So to get a, you should square root this. So the answer is 6. And to get b, you should square it. So the answer is 2. And to get c, this is the formula: a squared plus b squared. So it is square root of 6 plus 4. And the answer is square root of 10.
So we already have the value of a, the b, and the c. So we're going to find now is the center. So the center is represented by the h and the k, which is found in the equation. The h and the k. So to find the value of the h and the k, you need to equate this one into 0. So you need to equate this one into 0. So to find that, h is to x plus 5 is equal to 0, which is x is equal to negative 5. Y minus 2 equals to 0. You need to put this negative 2 into here, so this will become positive. So y equals to 2. So this is now your center. So the center is negative 5, 2. So we already have the value of the center, which is negative 5, 2. So we're going to plot it. 1, 2, 3, 4, 5. 1, 2. So this means this is your center. So to get your vertices, we need to use this a here as a distance from your center to your vertex. So we need to count 2.45 from the right and the left. So 1, 2.45. So this is your vertex 2, and we need to count to the left 1, 2.45. So this is your vertex 1. So our vertex 1 is negative square root of 6 minus 5, 2. And vertex 2 is square root of 6 minus 5, 2. So to find our co-vertices, we need to use the value of b as the distance from your center to your co-vertex. So we need to count up and down 2. So 1, 2. So this is your B1, BC1, and down 1, 2. So this is your BC2. So our VC1 is negative 5, 4, while our VC2 is negative 5, 0. So to find the foci, you need to use the value of C as a distance from your center to your foci. So the value of your C is 3.6, so we need to count from your left and right. So 3.6, 1, 2, 3.6. So this is your focus 1. Then 1, 2, 3.6. So this is your focus 2. So your F1 is negative square root of 10 minus 5, 2. While your F2 is square root of 10 minus 5, 2. So the next step is we need to find the lactus recta. Lactus recta is a line segment that passes through the foci. So to get the lactus recta is equals to 2b squared over a. So the value of your b is 2. So 2 squared over square root of 6. So this will become to 4 square root of 6 over 3. So we're going to divide it to 2. So this will become 1.63. So we need to count 1.63 up and down. So 1.63 is located here. And 1.63 drawn is here. Same as the other side. It's located right here and also right here. So we're going to find the asymptote. So the formula for your asymptote is y minus y sub 1 equals to positive negative mx minus x sub 1. So m is the slope. To get that one is positive negative b over a if it's horizontal, and positive negative a over b if vertical. Since we are using a horizontal hyperbola, so we're going to use this equation in their m.
We get the y sub 1's values from the k value of the center and the x sub 1 from the h value of the center. Our slope is positive negative square root of 6 over 3. Then we get the equations of our asymptotes. The asymptotes are the lines where the hyperbola does not touch.
Now that we have the imaginary box, we can draw the asymptotes. So this is it. And here. On the other side. Okay.
We may now graph the hyperbola.
So this is now our parabola.
Go.
Now after solving, we should get the eccentricity. So the formula of the eccentricity is c over a. So c over a, square root of 6, square root of 10 and square root of 6 is equals to negative 15 over 3.
For the directrices, we use the formula a squared over c to get the distance of the directress from the center, which is now 3 squared of 10 over 5. Transverse axis is the line from vertex 1 to vertex 2, which is equivalent to twice the A. The conjugate axis is the line from the covertex 1 to covertex 2, which is also equivalent to twice the B.
So we're going to transform this standard form into general form. So we need to find the LCD. So we're going to multiply this equation into 12. So this will become x plus 5 squared 6 minus y minus 2 4 equals 1. So we're going to multiply this by 12. So this will become to 2 x plus 5 squared minus 3 y minus 2 squared equals 12. So we're going to expand this equation squared plus 10 x plus 25 minus 3 y squared plus 4y plus 4 plus 12. The next step is we're going to distribute this 2 and 3 into the others. So this will become 2x squared plus 2 times 2x plus 50 minus 3y squared plus 12y minus 12. Yeah, then we're going to transpose this 12 to the other side. So this will become minus 12 plus 0. So combine like terms or simplify it. So this will become 2x squared minus 3y squared plus 20x plus 12y plus 26 plus 0. So this is your general form.
Now let's try this equation. First, let's find the center.
Group the terms with same variables and then make them into square of binomials. Add 1 and negative 4 on the other side. Divide both sides by 14. And here we have our standard form. So now we can find the center from the standard form, which is negative 1 and 2. A and B is square root of 14, approximately 3.7. And C is 2 square root of 7. Now, let's plot our center, vertices, convertices, using the number of units of A and B. Here are the points of our vertices and covertices. Then we plot our foci using the number of units of C. Then we get the latera recta, which is 2 square root of 14. We divide it by 2 in order for us to plot it. So here are the endpoints of the latera recta. Now draw the asymptotes and then graph the hyperbola. To get the directrix, we do the same, and the axis of symmetry is 2. Now we get the asymptotes. The asymptotes are y is equal to x plus 3 and y is equal to negative x plus 1. The eccentricity is 2 square root of 7 over square root of 14, then square root of 2, which is greater than 1, so therefore it is a hyperbola.
So now let's try another given. Wherein the center, the transverse axis, and the conjugate axis is given. Wherein the opening is left and right.
For the standard form, we get the h and k from the center, which is negative 2 and 4. The square of half of 8 is 16 and the square of half of 6 is 9. We have now the center, so we get the value of A, B, and C. A is 4, B is 3, C is 5. Then we plot the center, which is negative 2, 4, then the vertices, of which the distance from the center is 4, then co-vertices, of which the distance from the center is 3, Then the focus, of which the distance from the center is 5. So here are the points of vertices and the co-vertices, and the foci. Now we have to find the lateral rectum, which is 9/2. In order to plot, we need to divide it by 2, which then it becomes 9/4. Then plot it, the endpoints. Then we have to draw the asymptotes of the hyperbola. Then graph our hyperbola. The equations of our asymptotes is y is equal to 4/3 x plus 20/10, and y is equal to negative 4/3 x plus 4/3. Then we have to find the distance of the directrices from the center, which is 16/5. The lines are found on the x-axis, which is negative 26/5 and 6/5. And lastly, the eccentricity is 5/4, which is greater than 1, and therefore it is a hyperbola.
So that's it for today.
Hope you've learned something, guys.
Thanks for watching.
Bye-bye.